Hi, welcome back. Next, we're going to start looking at some different types of functions, but before we do, a quick little review. I recommend you pause this and see how much of this you can come up with, how much of this you can understand from each of these types of functions. I'll briefly go through it, but we'll cover this more as a warm-up in class, but you have a few minutes here to take that. All right, hopefully you came up with these and you can understand a little bit more about how these work, the different types of functions we've covered. We're going to start with a new type of function today. You may have studied them before, but we're talking about exponential functions. Exponential functions have this base form. We're going to call this our parent function. We're going to use 2 in place of a. Let's take a look at what the graph of these looks like. Here we have a graph of these. This graph is, again, in GeoGebra, it allows us to really look more at what's going on with these, so we can see how this function is behaving. This is an exponential function. You've probably at least heard about exponential functions before, but we have an a value, a b value, an h value, and a k value. It's a to the bh plus x plus 1 here. So you can see a is this coefficient here, what it does to the graph. I'll let you try and figure out how you would word that. These are important. We've looked at what these different parameters do to the graphs before, but as you can see, it changes the graph as we change a, if we take it back to 1. B, we're not going to talk a lot about changing b at this time. That's the base here. But h is very similar to what we've done before. And k. And notice this also has that same asymptote functionality to it that we've been talking about with the rational functions. There is an asymptote here. We'll talk about it, but you can see it is related to k, that value there. So that's what the function looks like. It starts off shallow, gradually growing, and then it shoots up and grows really quickly at some point. That will all depend upon how big your b is and how quickly it goes up. And again, you notice some things there. And then we have some fractional parts here that we'll talk about as a different. They're also exponential functions, but they're what we call decay versus growth. So we have growth and decay. We also have growth that looks not like growth, and then we have decay that's weird as well. So all this we'll look at in depth, but what's important to know is the basic shape of this graph is this. We've talked about shapes of parabolas, we've talked about other shapes, so we'll go ahead and move on from this and how we can graph these. So there's some key points we need to find. There's this intersection here, and then we need to have an idea of how inflected it is, how steep it's coming up, and then finding this asymptote. Those are the things we're going to have to be looking at when we graph these. So let's take a look here. We looked at the example there. Let's just go ahead and look. All right, so we'll take this and we can make this f of x, depend on. We'll make this f of x so we can talk about it easier. F of x equals this. So we can talk about f of 0. That's a half times 3 to the 0. Really important that you understand your rules of exponents here. Anything to the 0 power is, that's right, 1. So times 1, that equals a half. So we have 0 and a half. We'll start plotting some points in a minute. I also want to look at 1 because I think 1's an interesting point. So we'll talk about f of 1. And if we look at f of 1, that's a half times 3 to the 1. That's 3 halves, or 1 and a half. So at 1, we're at 1.5. And then I'm going to pick another couple points out here. Let's try f of 3. That might be on where we're going, but we'll just take f of 3. That's a half times 3 to the 3. That's 9 times 3 was 27, so that's a half of 27. So that's 27 halves. And if we take that, that's 22 and 1, and then 8. 17 is 6, well, 8. 17, 8.5, 18.5. So we're probably off the graph at this point, 3 and 18.5. Now let's take a look at what happens on the other side. What if we put in negative 1? If we look at negative 1, we have half times 3 to the negative 1. This is going to cause a lot of your memories to go, but that's a half times a third, because you have the inverse with the negative exponent there. So that makes it a sixth. And if we use our little calculator, a sixth is, as a decimal, 0.16. So we're just barely 0.16 repeating negative 1 at 0.16 repeating, just barely above it. So let's take a look at what we know. Now, asymptote-wise, can this function ever be less than 0? And let's look at the domain. Is there anything we can't put into this? Well, we've tried negatives, we've tried zeros, we've tried positives. It looks like we can put all those in. Nothing here is illegal to put in. We could put fractions in, it's just ugly. So there's the domain. If we look at the domain is not going to be a problem here at all. The domain is going to be domain, the domain So we look at the domain, and the domain is f is all real numbers. We can put everything we want. There's no problems with any domains. We don't have to division by 0 anywhere. We don't have anything. But the range, on the other hand, what we have coming out, we're not going to get anything that's going to be negative. There's no power of x I can make. It's going to make this thing go to a negative, and anything positive comes out. So we're going to have the range is y is always greater than 0. I don't even know if any number I can put in here to make this 0, because if I put it to the 0 power, as we discovered, that's 1, and the negatives, that's still positive, and positive. So we're not lying. So our asymptote is actually y equals 0 in this case, because we're never going to be less than 0. We're going to get close to it. As you can see, we're down here close to it. So let's go ahead and graph the line y equals 0 as our asymptote. Put it right here. There's our asymptote. And let's start putting in some of the points we identified. So we'll put in some of these points. We have 0 and a half right here. Let's make it a color we can see. 0 and a half is right here. And we have 1 and a half. 1 and 1 and a half is right here. And then to 3, we're clear up off the page here at 27, or at 18. Way, way up there, not even there. So we have to be way past that. And then over here at negative, we're just barely below that half at 16. So our graph looks something like this. It's going to come in, this is approximate. And again, that's not perfect because it's a sketch, but we get the idea. We know where these key points are, and we have a graph of it. That's all that you have to be able to do. Identifying this, being able to find a few points, that's what we're looking for. So let's go ahead and try another problem or look at some other things here. Again, a reminder, an asymptote is a graph the line approaches as x goes to positive and negative infinity, but never reaches. As it goes to infinity, we draw it with a dashed line. Important to see those. We have those asymptotes just like we do with rational functions. Let's review our exponent rules. So is this function, or is this value, this number, is this a really big or really small number? That's right, this is a really small number as we look at this. This is a small number because it's 1 over 2 to the 100. And 2 to the 100 is a really, really big number, but 1 over that's going to make it a really, really small number. So remember, these negatives make a reciprocal. So we have the negative exponents making a big function there. So let's take a look here at another one. This is f of x equals 3 to the negative x. This one should be much easier to graph because it's not got the exponent, the leading coefficient in it. But again, we're going to look. Let's define the domain and range right now. The domain is all real numbers because we're not dividing by anything and there's nothing we can't. The range, in this one, the range is always going to be y is greater than 0. So we can automatically put in our asymptote because we know we're not going to get anything close to 0 here. So there's our asymptote. And let's go ahead and start finding some points. We'll start with the point f of 0. That's 3 to the negative 0. Oh, I might have the range wrong because I didn't notice the negative here. We'll have to take a look at that. Let's look at f of 0. F of 0 is 1. F of 0 is 1. Alright, so this is really, we do have the range right because we have 1 and we're greater than 1 as the output. We know we can't go across this line because it's 1 is the asymptote and because we'll never get this number to be negative. But let's really look at what this function is. As we take a look at this, this function really is f of x to the 1 and 1/3 is our base to the x power. These are the same because of that negative exponent. So we really, this is what we're going to call a decay value, a decay function. But f of 0 is 1, so we're going to go ahead and graph that. F of 0 is 1. And let's try and find some other points. What would be f of 1? F of 1, now that is a third, because it's a third to the first power, which is a third. So we have 0, nope, we have 1 and a third. 1 and a third. Let's take a look at some negative numbers. F of negative 1. This is really going to throw some of you off, but you can get it. So let's go back to the original form of the equation. We have 3 to the negative 1, which, if you use your rules of multiplication, this is 3 to the 1, or just 3. So at negative 1, we're up at 3. Well, let's look at f of negative 2. See where we're at. And f of negative 2, we have 3 to the negative 2, which is 3 squared, which is 9. So at negative 2, we're at 9. And hopefully you can see that if I did f of 2, that's going to be 1/9. Does everyone understand that, I hope? Because you put the positive 2 in, and you'll get the fraction, and so you have 1/9. So that's just teeny. So here we have 1 as a third, and this one's even closer down here like this. We're approaching this line. But over here at negative, we're at 3. And over here at negative 2, we're at 9. 3, 4, 5, 6, 7, 8, 9 right here. So as we go ahead and graph this line, we will see that it's coming in like this. And approaching. And I missed it a little bit. You get the idea. And this should be like this. But we're close enough here. We get an idea of what this looks like. And we have a nice exponential decay type function. So again, the graphing of these, they kind of look funny. They're either going to go in towards it or they're going to go away from the asymptote. Identifying that asymptote is something I'll let you play with when you look at this, which is on the website. Play with this and see how we really are finding that asymptote and what affects it and what doesn't affect it. And you'll be able to get that, and we'll discuss it more in class. Let's see if we have any others. Just again, we talked about this before, but this function will never be less than or equal to, that parent function will never be able to take it equal to 0. Because there's no value you can put in for x that will make this go to 0. The smallest value that's positive we put in is 0, and true to 0 is 1. You go to fractions, to the 1/2, that's the square root of 2, which is still positive. If you went to negatives, negative 1, that would be 1/2, that's still positive. Negative 2 would be 1/4. So those rules of exponents that we studied before are really important to review. Maybe I'll put a link to a review of that on another website on our site if you need review of exponent rules. But will never be less than 0, which is one way we can come up with it. This is another one we're going to graph. We'll just get a real quick stab at this. I want to be done with this video so you can get to practicing some of this. But we're going to do the same thing. We're going to plug in some points and just see what we come up with. So again, I like using f function notation. So we can put this f of x. So I can talk about f of 0. F of 0 is negative 3/2 to the 0 power which is negative 1, because the 0 power is 1, so negative. So this is 0 and negative 1. That should give us some indication that our domain and range, again, the domain is going to be all real numbers, and the range in this case, because we're negative, will never be positive, because whatever we get in this power, we're going to take and multiply by negative. So the range in this case is going to be y is less than 0. So everything is going to be below the line, and our asymptote will still be this horizontal line at 0, and then everything below it. But we got to see if this is going to go away from this asymptote, or is it going to come in and go towards the asymptote? I would ask you to predict that before we finish here. You know this is 3 halves, or 1.5. So is this going to be a decay-like function, which goes away, or growth, which goes away from the asymptote, or a decay, which comes in towards the asymptote? It's in the negative direction, so it's a little bit confusing, but we can understand it, and we can try. Let's go ahead and try plugging in some more values. Let's take a look at f of 1. See where it goes at 1. That's negative 3 halves to the 1, which is negative 3 halves. So 1 is negative 3 halves, which is 1.5. Let's start graphing these points. We have this point right here, 0 and negative 1, and then we have a point over here at 1 and 1.5 right here. Looks like I'm going away from the asymptote. That would be growth in the negative direction. Let's plug in negative 1 and see what we get. So this is f of negative 1 is negative 3 halves to the negative 1. You might be tempted to say the negative just cancels out with that negative, but remember, a negative exponent just is a reciprocal function, so it's going to be equal to the reciprocal of 2/3, or 3 halves, which is 2/3, which is a number, and we can graph that at negative 0.6 repeating. So we're over here, and negative 1 is just a little bit more than a half right there. Graph that there. So as we look at this, it looks like it's coming in like this. We could plug in 2. Let's just do 2 for fun, just so you can practice these exponents. That's negative 3 halves squared, which is negative 3 squared over 2 squared, which is negative 9 fourths, and negative 9 fourths is approximately 2 1/4 negative. So that's 2 1/4, so 2 is negative 2 1/4. So 2, 1, 2 1/4. Not going very fast, but it is going up. So we have this as our line. I'll see how close I can get these. And there we go. And when I meant up, I was setting it down. So there we have it. Another graph for you to look at. That gives you enough to practice graphing on your own. We'll try some in class when we get back to class. Hope you've enjoyed this. Have a great night.